10 volts, which in this case it's saying the valve is closing at 10 volts. So that would be direct acting. Reverse acting would be a case such as this, shown as humidity. As the humidity is increasing, the voltage is decreasing because it's a normally open valve and we're going to the open position on the valve. So here we talk about the same thing we were talking about earlier. Works the same on valves as it did with the dampers. You know, normally closed, normally open versus fail closed, fail open. Yeah, I don't think we have to go through that whole scenario again. It's the same as what we talked about earlier. Brian, do you have your notes to make a note of that?
Yeah. Which way were we making a note of?
They're under the valve stuff. They're going through that same normally closed, normally open.
You don't want to do it again?
They're all pretty much the same slides. I don't think we really need to do the same thing over again. They corporate may want to change it, they may not, but I will be taking it out of my presentation. Unless I see something going through here that looks different, but so far it all looks the same.
The 6-way does not label AB ports.
It's not labeled like that. How's it labeled?
It's not labeled at all.
Oh.
Hot luck. Figure it out. What's it called?
ANSI ratings. This is something new to this presentation, go through the ANSI ratings. We don't do a lot of talk about it, but talking about the difference between body pressure and leakage, class ratings. ANSI 125 versus ANSI 150. Those refer to the flange dimensions and the bolt holes. That's really all I have to say about that portion. You can see here with the different flanges, the slide shows the tightening sequence so that you get a nice tight seal on the valve. Because if you tighten all these bolts up here, then you're going to be leaking down here. So, you know, it's better to move around and tighten around rather than just every one as you go. ANSI body pressure ratings, see here, class 125, class 250, class 150, class 300, and the different temperature ratings associated with those. Leakage rates. Typically we're going to be looking at ANSI class 3 or 4. That's what most manufacturers use as their ratings for their leakage. Valves. Now, if you start getting some of if you really need less than that, you've got your class 5 and class 6, and then you're getting some really expensive valves to do that kind of tight control or tight close off. So class C, maximum seat leakage allowable. See how minuscule it is. I mean, on a 1-inch valve, 0.15 milliliters per minute. Not really milliliters, but that's not a lot. So that was the real brief introduction to ANSI classes. Any questions on that? I went through it quick. It is what it is, really. All right. Now we're going to talk about valve sizing for pressure-dependent valves. How many people in here have to do valve sizing? Okay.
That's Bob's job.
I might go a little bit faster since there's only a few of you, but really we'll talk a little bit about this stuff. One of the things I'll say is that we have that Select Pro sizing and selection software that, you know, if you don't already have your own Excel spreadsheet or whatever the case may be, set up to help you do your sizing, the tool is a nice way to go.
The phone works just
What's that?
The phone works just as well.
Yeah. Yeah. The, no, I'll talk about it. So, step-by-step process, you calculate your CV, select your valve, so forth. What kind of information would you like to have? Well, you want to know what the application is, what the media is, what kind of close-off pressure, two-way or three-way. You know, some of this information you rarely get, but you certainly need to know if it's two-way or three-way. If it's three-way, is it mixing or diverting? What's coil data? It's GPM, the delta P, and then you can calculate the CV. You know, as a rule of thumb, if you're trying to calculate for a modulating control valve, just cut the GPM in half, assuming you know the GPM. Reason being, and we'll get to it in a minute, but the formula for calculating CV is GPM divided by the square root of the pressure drop. Typical pressure drop for a modulating control valve is 3 to 5 psi. If you use 4, square root of 4 is 2, so you're just dividing your GPM in half. And that gives you a quick, easy way of calculating approximately what your CV should be. Other things that are required as far as the actuator side of things is fail-safe, or do you need fail-safe, what kind of supply voltage, and what kind of control system. This is one of ASHRAE's definitions. CV is amount of water flow in GPM through a fully open valve with a 1 psi pressure drop. It's also at 60 degrees as far as the temperature goes. So if you have a CV that's too high, it means you have an oversized valve. You're going to get sloppy and energy and inefficient performance. If it's too low, it could result in insufficient flow and you can starve the coil. When we're sizing control valves, we always go a CV higher than what the calculation is if it's not exactly on. So for example, if we calculated a CV of 4, well with Belimo our half-inch valves go from a 3 CV and then the next one is a 4.7. We're going to go with the 4.7 CV. Make sure we're covered and not going to starve the coil. This is the formula I was talking about, GPM divided by the square root of the delta P. So as an example, valve must pass 40 GPM with a delta P of 4. What's that CV going to be? A quick test in the middle.
3,000.
Yep, I heard somebody said 20. 40 divided by the square root of 4 is going to be 40 divided by 2 or 20. We won't go through the exercise here, I'll just talk through it. So if you have a GPM of 17, delta P of 4, CV is 8.5. 90 and 4, CV is 45. Then 825, but with a drop of 3 pounds, then you're going to get a CV of 476. So, this is right out of our PGPL as far as the valves that we have available. So we're trying to find a valve with a CV of 20.
The one they pick's not on here.
What's that?
The one they pick isn't listed.
Yeah, of course not. So, we don't see any with the CV of 20. That's because we don't have a valve with a CV of 20. So we could go with the valve with the CV of 24, but one thing I'll point out here is that has an asterisk next to it. What that means is that valve doesn't have a characterizing disc, which means piping geometry will play a factor here. That's a 3/4 inch valve. If we were to install that in a 1 inch line, I think that shows up in the example, the CV would be less than the 24.